Right, so now we'll move on to solving system of equations or solving simultaneous equations using the Kramer's rule. It's a very simple rule and it's called the Kramer's rule because it was, I don't know, it was invented by Kramer or something, I don't know why, but we call it the Kramer's rule. So in the Kramer's rule, all you have to know is to find the determinant, right? So we'll be using the determinant to find the Kramer's rule. So a system of equations, right? When solving system of equations in 2 or 3 unknown using determinants, follow the steps below. So first, our system of equations that will be given to us in a question will be expressed in this form, right? This is the coefficient matrix, this is the unknown matrix, and this is the right hand matrix, right? So right, so that's it. So let's test with this example using the Kramer's rule. So we have one example here. We have two equations, 5x minus 3y is equal to 28, and then minus 2x plus 4y is equal to 14. Perfect. So now we have to change this, right, into this form. Now, into this form. This is the form we need. So we take all the coefficients of the variables. So 5 here, minus 3 here, minus 2 here, and 4 here. And then that forms the matrix A. So that's A. And then X is just all the variables inside the equation. So we have two variables, X and Y. So we call it the variable vector or matrix. And then B is the right hand side because the number is there. So 28 minus 14 is positive. 28, 14. Perfect. We're almost done. Once we get this, we're almost done. Then we apply the real Kramer's rule. In the Kramer's rule, it gives us the value of x by this. Right? And the value of y by this. Right. So I'll define the terms using. So x is given by the determinant of a, right? With subscript x, right? It's a subscript, it's not a product. Divided by determinant of a, and then y is given by a subscript y determinant of a, right? We know how to find determinant of a, but what of this? Right? So ax is basically the determinant, right? Is the determinant of A where the first column of elements is replaced by B, right? Where the first column of element is replaced by B. That's AX. That's it. So same for AB, AY. So is the determinant of A where the second column is equal to B. What do I mean by this? So let's take this A. A is 5 minus 3 minus 2 and 4. So AX is equal to, this is the first column. When we place the first column of element here by B, then that forms ax. So this, we will place this. So let's see. So that would be 28 and 14. Right? Oh, 28, 14. Then we'll have the rest as minus 3, 4. That's ax. Now let's see ay. In ay, we will place the second column of elements by b. This is b. That means b will come here and replace this. Right? So we'll have 5 minus 2, 28, 14. Perfect. Now that we have ax and ay, we can find the values of x and y. So x is given by ax over a, the determinants of both, right? So let's calculate them. Determinants of this will be 28 times 4 28 times 4 minus negative 3 times 14. That will be plus 14 times 3. The answer is 154. Divided by determinant of a. Determinant of a is 20 minus 6. That's 14. This gives us 11. So x is equal to 11. Then y, we have ay over a. What's ay? Ay is here. The determinant of ay will be 5 times 14, which is 70, right? Plus 2 times 28. I said plus because of the minus 2 there. So that's 126 divided by 14. This gives us 9. So in the end, we get x to be 11, and then y is equal to 9. This is perfect. So easy, right? This is so easy. So yes, that is how we solve the Kramer's rule. All you have to know is these formulas. Right. Oh, that is Kramer's rule. So we use Kramer's rule to solve these examples here. They are very simple. And then we'll try the review exercises. In example 1 is addition, subtraction, and multiplication. And in example 2, which of these has no multiplicative inverse? So how do we know that a matrix has no inverse? It's only when its determinant is equal to 0. So we'll find all the determinants and then see the ones that are 0. The ones that are 0 have no multiplicative inverse, right? Given that a is this basic, we can do it. We can do this a squared minus 2b. A squared is just a times itself minus 2b. We can solve this. Then this one is the same thing. Find the values of m squared. M squared is m times m. M cube is m times m times m, right? So what we do is we find m squared, and then we use the answer of m squared to multiply m to get m cubed. Then we use that to multiply m to get m exponent 4. But this is m exponent 1, negative 1. That's the inverse. This inverse, and then we know how to find inverse. Right? Perfect. Find x and y given that m is equal to this. Right? We can find this. It's just x is equal to this and Okay, given that m, this is equal to, so we have m here, we come and substitute m here, we multiply, and then we find x and y. It's also simple. This is the key word here, has no inverse. Has no inverse means determinant is equal to 0. So you find determinant of this, they equate to 0. Right? It's so simple. It's all simple. You can solve all of them. Right? Seeing here, the simple, 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 simple. These are all examples that we could try to, make our understanding, and then download more, muscle memory on that. Right. So that's basically it for matrices. So yeah, you should try these examples. And then check the answers at the back of the book, because it has the answers there. And so if you want to solve them, you have to pause the video and then solve